patient, which is detection of sore risk regions on the foot sole with digital image processing and passive thermography in diabetic patients. And Rafael Vallare is presenting.
Yeah.
You can share your presentation, please.
Yes. Is it displayed?
Not yet. It's coming. Now we can see it.
Yeah.
Yes.
Ready. Welcome and greetings. My name is Rafael Vallare, and I'm the presenter and corresponding author of this paper entitled Detection of Sore Risk Regions on the Foot Sole with Digital Image Processing and Passive Thermography in Diabetic Patients. This work is a collaboration between the Crown Laboratories in France and Sinvestav in Mexico. A brief background of our problem is that diabetes mellitus is one of the problems that affects among population worldwide, and unfortunately every year increases in terms of numbers. A common complication of these patients is the appearance of ulcers on the sole of the foot, which the statistics says that approximately between 15 and 25% of the patient will have these ulcers by several reasons. The most common one is due to inappropriate walking shoes. So, given this problem of the diabetic foot, our main goal is to study the surface heat distribution as input of our proposal. For instance, we will call it as a black box algorithm in such way that the output of this black box we will display some areas that could develop tissue injuries related to the heat distribution in order to support an early diagnosis of the diabetic foot plus an ER thermography study. So the proposal in this work is resumed by the following diagram, in which I will explain following each stage, starting by the data acquisition protocol, how the data was retrieved as temperature data, and how all this information was processed by the following stages in order that at the end we will have a binarized error image that will display regions that do not have abnormal temperature areas. So for a start, the acquisition protocol, the sensor we use is Lepton 2.5 radiometric ER sensor. The resolution of this equipment is 80 by 60 pixel. The pixel size is 17 micrometers, and this sensor has the capability of measuring the near infrared spectrum from 8 to 14 micrometers. The special feature of this sensor is that it is possible to retrieve the radiometric data in order to estimate the temperature in the frame region. About our patients, we had a universe n equal 12, in which all the patients were diagnosed with diabetes mellitus without a clinical history of diabetic foot or at least visible anatomical alterations or inflammations. This protocol was approved in the Mexican National Rehabilitation Institute. Our patients were put in dorsal position and the foot was left to cool for 10 minutes as suggested in the passive thermography technique. Afterwards, our ER scanner sensor was put or placed 20 centimeters far from the foot, and we took a frame capture for every patient. Then, the information was retrieved as an array of 14-bit data, in which with a characteristic equation that was developed specifically for this purpose, we can interpret this 14-bit data into a temperature map. At this point, I would like to make a parenthesis to clarify that given an array of values, for example, this array of 3 by 3, it is possible to interpret them as a color image with a color scale. For instance, we can observe that, for example, the lowest value will correspond to the blue color, and the highest value, 9, will correspond to the color red. In such way, these temperature maps that is an array of values can be interpreted as commonly known as an ER image, in which every color intensity is directly related to the temperature intensity. Given this definition, before we interpret this data, we have processed it before. The first stage was to organize the data by range normalization. it is possible to rescale the amplitude of the data, but the shape of the distribution and the attributes will remain the same. For example, we have an original data as only example that has a scale of 0 to 48. Then after the range normalization, we can observe that the scale is going from 0 to 1. This allows to find several patterns. For example, the first one is that an advantage of ER thermography, infrared thermography, is that usually the objects of interest are warmer or at least colder than the background. In such way, we have found that arranging the data, the values that are higher than 0.8 correspond to the region of interest. Meanwhile, the values that are below 0.8 correspond to the background. In this sense, it is possible to apply, for example, a high-pass filter, which we can observe that after this stage, values that are higher than 0.8 remains with their same value, and the rest of the values that are lower, we can put in 0. So we can see an example of this process. Not only we can eliminate or segment the region of interest regarding the background, also we can see that with this process we can enhance the contrast of an infrared image, which the region of interest is highly contrast respect the original image. After this process, we could observe that 4 of our patients had possible abnormal temperature distribution. As we can see in this region of the metatarsal area, some region of the fingers, and finally also in the heel zone. Also, we found 6 patients that had a normal temperature distribution. Here I show or display some example of how it looked like a normal temperature of the foot, which supports the hypothesis that not all patients that have diabetes mellitus can develop diabetic foot. And finally, unfortunately, we had 2 cases with origin fault in the acquisition protocol stage because our algorithm in this stage is not capable of segmenting the region of interest because there are some areas that have higher temperature than the sole of the foot. So isolating the 4 possible cases, we can observe in this diagram that first, we start processing the radiometric data interpreted as temperature in Celsius scale, then it was interpreted as infrared image, and then it was converted into the grayscale intensity domain in order to apply some classical digital image processing techniques to try to detect some regions that could develop injuries in terms of temperature intensity. So once we transform the image into the grayscale, we binarize the image through the threshold method also, which is one of the most classical. The also threshold method is just only a variance within 2 classes. For instance, we have 2 classes, the region of interest and the background. And the variance is calculated as such as a statistic equation, which xi corresponds to the value of intensity of gray levels of every single pixel. Mu is the average of all the image intensity, gray intensity pixels, and finally n is the resolution of the image. After we binarize the image, we have these results. We can find that it is possible to display some regions in terms of temperature intensity. However, in terms of computational methodology, if we want to, for example, detect how many regions exist in the sole of the foot, unfortunately, we will detect several regions because every scattered picture will be interpreted as a single area. So a proposal for solve this problem was finally to erode these binarized images. We proposed an structure element in the erode method, in which our structure element was a matrix of 13 by 13 with center X, which our center X is an element 3 by 3 with center white. In such way, we can see in this example that black islands can be turned into a single region, and the scattered white pixels was reduced to a single area. So here I present the results. of our 4 patients, in which we can see the sole of the foot represented with a single area that is related to high temperature intensity regard the rest of the sole of the foot. In the metatarsal area, fingers, and also in the heel. So we can conclude from this paper that our algorithm proved the feasibility to display regions with higher temperature than the rest of the sole, which commonly are ready to prone lesions, as an indirect way to relate the grade level intensity related to temperature intensity. Also, these cases can be classified as a normal temperature because it is expected that the food should have homogeneous temperature because it was exposed to passive thermography. It means that the food was left to cool with the ambient temperature, so we should not expect to have areas that have higher temperature than the rest of the sole. As perspective, we can say that retrieving the data could be used as an exhaustive numerical analysis for pattern recognition, which usually in thermography is known as thermal fingerprint. Also to support an anticipated diagnosis based on support systems such as medical thermography. Also, this idea support the hypothesis of processing radiometric data before of applying any classical digital image processing techniques. As acknowledgement, I would like to thank to my French colleague, Bing Fan, the technicians of our laboratory, Hugo Cepeda and Ruben Perez, and finally a special thanks to Dr. Cynthia, Dr. Hector, and Ilse for retrieving information in this paper and the treatment of the diabetic patients. Thank you very much for your attention and time.
Thank you very much, Rafael. We are going to start with questions, please.
Yes.
Any question? Yes, there is a question. Please.
Rafa,
yeah.
You use 2-dimension images, is that right?
Yes, it's right.
2D images, is that right?
Yeah.
You didn't mention in your presentation that you are planning to work with 3D images. So I have one question about it, because what would be the advantages of using 3D images instead of 2D images?
Yeah, I must clarify that this project of 3D images is not totally related to this work, because here I try to present the importance of the radiometric processing. However, the importance of using 3D images or a 3D model instead of studying every single image is in terms of time and facility for the physiologist. It means that we can have a single entity that can be analyzed to observe temperature differences, some regions that can be inflamed that are not possible to study by single imaging. So to have a single entity could also save time and also give a better interpretation to the medic. Yeah.
I think that you are focused now on the sole of the foot.
Yeah.
Because I think that the damages that can be, that the parts that can be affected by the diabetic foot is mainly the sole. But
yes.
Is there any other areas of the foot that can be affected by the diabetes, so that 3D images can be more useful or not?
Yes,
do you know what I mean? Am I clear?
Yes, of course. Some colleagues of our laboratory has also researched about these problems in terms of MACUL's study with digital image processing that also supports this hypothesis that the lesions that are not only appearing or develop in the sole of the foot. This problem of the diabetic foot, in fact, affects in the lower limb. So supporting the idea of developing or displaying also a 3D model, it supports the idea that it's important that not only focus in a specific region, that's a problem that remains in the 2D thermography. that only we have a single perspective instead of a 3D model that we have a whole perspective of the lower limb.
Okay, thank you very much. It was a really nice presentation.
Thank you very much.
Congratulations.
Thanks.
Thank you for the question, Arturo. I can see another hand, but I cannot see who is it. Could you
Maria
please?
Fernanda.
Thank you.
Hello.
Hello.
So the position of the food, does it have any influence on your results? For example, if it's fully like erect or inclined to one side or the other, does it have any influence on the temperature, or it's not an important factor?
Yes, it's an important factor. Let me find the corresponding slide. Here we can see in the third case, the right one, that this actually it supports your question. The sensor was not placed exactly in front of the sole of the foot, so we can see that part of the lower limb was captured and had higher temperature. So yes, it did affect in this study. It is fundamental to try to keep it as parallel as possible.
And can you do like a I don't know, like a base or something to put the feet in, so you can control that? Or
yes,
it's not necessary?
Actually, the foot they are placed in a base that we try as much as possible to isolate the background. However, some areas still are not totally covered. So every day in our laboratory, several colleagues are trying to improve this base. Sometimes we have some designs that are in 3D printed. Also, we use pink foam that is a heat isolator. But yes, that's still a remain problem, not only in our laboratory, in several laboratories that share the same purpose.
Okay, thank you.
Thanks to you.
Thank you, Fer, for your question. I can see another hand raised too, but I cannot see the name.
De la Rosa Eric.
Hi, Rafa. Thank you very much for your presentation.
Yeah.
I have one question regarding the information you presented, like I think it was in your first slide. So you mentioned that you are thinking about your model as a black box one.
That's right.
Can you please explain that a little bit? Why do you think it's a black box algorithm?
Yeah, I presented as a black box algorithm because the input we will have in this stage, it's first a radiometric information. They are data and not image. But after the data is processed by the black box, our black box algorithm, at the end we will have a binarized image. So that's the reason. It's a collection of processes that at the end will help to get islands that in computational terms can be detect the coordinates and also retrieve the temperature information when we compare it to the input.
Yes, I was asking this because, for example, when you compare like your procedure with, for example, a neural network or maybe another kind of machine learning algorithms that are actually like black box models because you cannot really understand what is happening inside their gut, right?
Yeah.
So, but I mean, in your case, it is really explicit the way you are processing your data.
I understand. Yeah, I guess I misunderstood the term. Yeah.
Okay. I also a second question would be if you had some cases where at the end of your procedure you ended up with two different areas of interest after applying all these steps.
Yeah. Yeah. I may say that the first region of interest first is the sole of the foot, and then it is intended to segment just only the regions that have higher intensity than the rest of the region, the first region of interest.
Okay, got it. And when you already have this binary image, do you think you can collect more information from it? For example, counting the number of pixels that belong to certain areas, or how do you think this could be used?
Yes, actually, this is a kind of a spoiler question, because actually we have retrieved the coordinates of every single white pixel of every island, and comparing to the original temperature map, we can retrieve the original temperatures. So we use this information to compare the average temperature differences. It means the next paper I will present, we know in quantitative terms, in quantitative way, what is the difference between the salt average temperature regard the white island.
Oh, okay, that is really interesting. And also, I'm also thinking that you can even go beyond that, and for example, have a series of pictures for the same patient, in several sessions, and you will be able then to kind of capture some progression in the areas.
Yes, of course, and that's a very interesting question, because sometimes it is not always exposed, this problem, how patients can be as much as possible constant with their treatments, and also their compromise to collaborate with the investigation. No, this protocol, which it was approved by a research institute, unfortunately, not always the patients are constant. So that's challenging that remains beyond any technique we apply. Sometimes there are things that are out of our hand. But that's an interesting question.
Yeah. So thanks, Rafa.
Thanks to you.
Thank you very much, Eric, for your question. Last question, please, Wilfrido.
Yes, thank you. Thank you, Rafa. I have a question. Did you use another kind of morphological operators? You use erosion, but I want to know if you use another, for instance, closing, opening.
Not really, because once it was the first method I applied and it worked, so I didn't continue checking in another techniques.
Okay, because when erosion makes the image wider than the original. Yes. I don't know if this effect is a problem in your method, because in that case you need to apply a dilation to make the size of the image almost equal to the original one. And I don't know if this is a problem. The erosion becomes wider, the area you want to analyze.
Yes, actually, yes, because the most narrow is the area, the more we can retrieve only the temperatures that are related to the abnormal temperature region. If I make it wider, I would have more data, more pixels that are related maybe to regions that corresponds to the normal temperature behavior. So I try to make it as narrow as possible in purpose to only retrieve the temperature that are, for example, we can see in the third image, that are only related to the most red area.
Okay, thank you, Rafa.
Thanks to you.
Thank you very much for your question, Wilfrido. And thank you very much for the presentation, Rafael. We are going to continue with our next presentation.
Of course.
Okay, we are going to continue with